In this lecture, I am going to discuss some more numerical example based on periodic signal. Uh, Let us consider first numerical example. The question is, so that the signal xt, which is equal to xt equal to e to the power j omega t, will be a periodic signal, and its fundamental time period will be t, which is equal to 2 pi by omega. So, to solve this numerical example, you have to use the properties of a periodic signal. The one of the most important property of periodic signal is if any signal is periodic in fundamental interval of t, then that signal can be written as can be written as xt plus t will be equal to xt for that signal, where t is its fundamental time period. It means you can shift periodic signal in one time period by one time period either in left direction or in the right direction. Its characteristic will not change. So we will use this property to prove the signal xt equal to e to the power j omega t is a periodic signal. So if xt equal to e to the power j omega t, then what will be the value of xt plus t? If xt is e to the power j omega t, then xt plus t will be equal to e to the power j omega, and in place of t, you have to write t plus t. And now you can break this expression in two exponential term. E to the power j omega t will be one term, and e to the power j omega capital T will be the other term. And this is equal to xt, you can see here. In place of e to the power j omega t, you can write xt into this term, e to the power j omega t. So xt plus t will be equal to this. Now, the signal xt will be a periodic signal when xt must be equal to xt plus t. So from this expression, uh, you can see that xt plus t will be equal to xt only when this term e to the power j omega t equal to 1. E to the power j omega t, when e to the power j omega t is equal to 1, under this condition you can say xt plus t will be equal to xt, and the signal xt will be periodic signal and its fundamental time period will be t. Now you have to determine the condition. So the condition is e to the power j omega t equal to 1, or e to the power 1 can be written as e to the power j into 2 pi. E to the power j 2 pi will also be equal to 1. So in place of 1 you can write this, and now you can equate these two power. Omega t will be equal to 2 pi when you will equate the power, and t will be equal to 2 pi by omega. So you can say that this signal xt equal to e to the power j omega t uh, can be a periodic signal, but its fundamental time period should be equal to 2 pi by omega. Or you can say if fundamental period of uh, xt equal to e to the power j omega t is a periodic signal with fundamental period of 2 pi by omega. So you can directly use this formula. For example, I am asking you whether this signal is periodic or not. E to the power j 2t. This signal is periodic or not? So directly you can say yes sir, this signal is periodic signal because xt equal to e to the power j omega t is the periodic signal. And if I ask you for its fundamental time period, then its fundamental time period will be 2 pi by omega. In place of omega here 2 is given, so 2 pi by 2, and its fundamental period will be pi. So directly you can use this concept to solve this type of objective problem. Now coming to the next numerical example. In this numerical example you have to check whether the signal is x1t and x2t are periodic or not, and if it is periodic, then what will be its fundamental time period. Same property you can use. If x1t is periodic and its fundamental period is t, then x1t plus t should be equal to x1t. If under any condition x1t plus t can be equal to x1t, then you can say under that condition the signal 15 sine 15 pi t will be a periodic signal. So if x1t is 15 sine, x1t is sine 15 pi t, then what will be the value of x1t plus t? What will be the value of x1t plus t? x1t plus t will be equal to sine 15 pi, and in place of t you have to write t plus t, or you can write sine 15 pi t plus 15 pi capital T. Now you have to think under what condition x1t plus t will be equal to x1t, or you can say when x1t plus t equal to sine 15 pi t. This is possible when this term is equal to 2 pi, because sine 2 pi plus theta is sine theta. So if 15 pi t will be equal to, if 15 pi t if 15 pi t pi into capital T will be equal to 2 pi, then obviously x1, then obviously x1t plus t will be equal to x1t, and you can say the signal xt is periodic signal. So this is the condition under which you can say the signal x1t is a periodic signal, and from this expression you can determine its fundamental time period. Its fundamental time period will be 2 pi by 15 pi, or 2 by 15 second. 2 by 15 second. So you can say the signal 15 pi t, sine 15 pi t, cos 15 pi t, or are the periodic signal, and its fundamental period will be 2 pi by omega, where omega is 15 pi. So in conclusion you can say the signal xt uh, equal to sine omega t will be a periodic signal, and its fundamental period will be 2 pi by omega. Similarly, you can check this is also sine omega t. So this will also be a periodic signal, and you can show by this the same steps also. And its fundamental period of second signal will be 2 pi by root 2. 2 pi by root 2 pi, because in this signal omega is root 2 pi. So its time period will be 2 pi by omega. So omega is here root 2 pi, or when you will solve this expression, it will become root 2. So this signal is periodic and its fundamental period will be root 2 second. Similarly, any signal of the form xt equal to a sine omega t will be a periodic signal and its fundamental time period will be 2 pi by omega. Now I'm coming to the third question. Third question is, you have to show this signal is periodic only when 2 pi by omega is a rational number. This is a discrete signal, and according to the property of discrete periodic signal, any discrete signal can be periodic in fundamental interval of n when xn plus n will be equal to xn. Here n and capital N both are the integer. You must remember this. So we will use the same concept to prove this statement. Now if xn equal to e to the power j omega n, then what will be the value of xn plus n? Xn plus n will be, in place of n you have to write n plus n. So it will be e to the power j omega n plus n. And now you can write this expression in the terms of 2 exponential. First term will be e to the power j omega n, and second term will be e to the power j omega capital N. And e to the power j omega n is xn. It is given in the problem, into e to the power j omega into capital N. This is xn plus n. This is xn plus n. Now, when xn plus n will be equal to xn, then only the given signal xn will be periodic. So from this expression you can check under what condition xn plus n will be equal to xn. This is possible. This is possible when this term will be equal to 1. When this term will be equal to 1, then xn plus n can be written as xn, and the signal will be a periodic signal. So for the periodicity of this signal, the term e to the power j omega n must be equal to 1, or 1 can be written as e to the power j 2 pi n. So you can equate the power. So when you will equate the power, omega n will be equal to 2 pi n, 2 pi n, and 2 pi by omega, 2 pi by omega, 2 pi by omega will be equal to capital N by small n, and both are the integer. So this ratio will be a rational number. So in this way you can say if 2 pi by omega is a rational number, then this term will be 1 and xn plus n will be xn, and signal will be periodic and its fundamental interval will be n. In this way you can prove this problem. In next lecture I will discuss some other types of signal, energy signal, power signal, and some of the test signal, for example unit step signal, ramp signal, etc. And I will discuss the property of those signal also. This is all about the periodic signal, and you can go through previous video also. In that video some more problems have been solved already, and the video link is shared with LMS, so you can go through that video. And also a PDF document related to this problem is also uploaded in the name of tutorial 1. So you can go through that PDF file. That PDF file is uploaded on LMS. So you can download from uh, that site and you can solve all of these problems.